Hello everyone. Again I have been here like আজকে যেটা নিয়ে ডিসকাস করব আমরা সেটা হচ্ছে চার্জিং অ্যান্ড ডিসচার্জিং অফ ক্যাপাসিটর in DC transients. Means whenever the DC circuit is being switched on or off, then how a CR circuit will behave, that we will see. Okay, তাহলে ফার্স্ট আমাদেরকে নিয়ে ডিসকাস করতে হবে যে একটা ক্যাপাসিটার, যেরকম আমরা আগের দিন করেছিলাম, যে একদম ইন দ্য ভার্জ অফ সুইচিং অন অ্যান্ড অফ, সেই টাইমে কি হতে পারে, লাইক transient state conditions just before switching on, and in case of steady state condition what will happen, that we will understand. Okay, তো এইখানে কি আছে দেখো, বেসিক ফান্ডাটা হচ্ছে আমরা যখনই ক্যাপাসিটার নিয়ে কথা বলবো, ক্যাপাসিটার শুধু বলা মানেও সেখানে একটা রেজিস্ট্যান্স তোমাকে কনসিডার করতেই হবে, বিকজ পিওর ক্যাপাসিটেন্স, পিওর ইন্ডাকটেন্স, দে ক্যানট এক্সিস্ট অ্যাকচুয়ালি. তো দ্যাট ইজ ওয়াই উই অলওয়েজ কনসিডার আ সিআর সার্কিট, নট অনলি আ সি সার্কিট. ওকে, but yes, ideally you can have a C circuit itself, but practically it is difficult, it is not possible actually. Okay, so if we are having a DC and say there is a switch, okay, now we are considering that when the switch is not yet connected, switch is at connected মানে সুইচটা কানেক্ট হচ্ছে at t is equals to 0 this moment. okay, তার মানে যখন t is equal to 0 minus, switch is not connected, মানে switch is at off position, switch off, and t is equals to 0 plus means the switch has been connected, means this is a switch on position. Okay, ठीक है ना. Now about the capacitor, we have talked previously that capacitors, they capacitor opposes the change in voltage. Okay na, capacitor opposes the change in voltage. Okay, so now whatever there is, if we are just applying a voltage, if the voltage is constant, then capacitor will try to maintain it constant. Then sir, in case of DC it is a constant voltage, why you are saying so, কি না স্যার, না এটা হবে ওইটা হবে, বিকজ আমরা জানি যে যখন ডিসিটা 0 থেকে ম্যাক্সিমাম অবধি যাচ্ছে তখন কি চাই, তখন ইট নিড সাম টাইম টু রাইজ. ডিসি কারেন্ট কিন্তু আমি সুইচ অন করলাম অ্যান্ড দ্যাট মোমেন্ট, মানে ধরো আমার এখানে 0 রয়েছে, আমি সুইচ অন করলাম, ওই মোমেন্টেই ওটা ম্যাক্সিমামে পৌঁছতে পারে না. দিস ইজ অ্যাকচুয়ালি আইডিয়াল কেসে আমি বলতে পারি, বাট প্র্যাকটিক্যালি ইট ইজ নট কারেক্ট. আর ডিসি কারেন্ট টু রিচ দ্যাট ম্যাক্সিমাম স্টেট, it needs a certain time interval, it needs certain time, it may be millisecond, it may be microsecond, but it needs this kind of time. Okay na, so whenever that changes occur, the capacitor will oppose when the change is in voltage state. তার মানে আমি যখনই ভোল্টেজটাকে চেঞ্জ করতে চাইবো, ক্যাপাসিটার উইল অপোজ ইট, ক্যাপাসিটার উইল ট্রাই টু মেনটেন দ্য ভোল্টেজ কনস্ট্যান্ট অ্যাক্রস ইট. ওকে, তাহলে দেখো সুইচ যখন অফ কন্ডিশনে ছিল তখন এখানে ক্যাপাসিটার অ্যাক্রসে ভোল্টেজ কত ছিল, বিকজ দেয়ার ওয়াজ নো চার্জ ফ্লোয়িং, দেয়ার ওয়াজ নো প্রিভিয়াসলি স্টোরড চার্জ, means the capacitor was in zero charge condition, means the capacitor was having a voltage of 0 volts. okay, ক্যাপাসিটার অ্যাক্রসে কত ভোল্টেজ ছিল, দ্যাট ইজ 0 ভোল্ট, when the circuit is not is in operable condition, means switch is at off position, এখনো অন করিনি আমি. now if we turn on the switch, means what, circuit is now closed. if the circuit is closed, then also as just before this time, at this time the voltage was at 0 volt, whenever I have connected the circuit, the capacitor will try to maintain it at 0 volt, because it is the property of capacitor. Capacitor always try to maintain the voltage fixed, means a moment earlier and a moment later it will try to maintain the balance. So what conclusion that we can make, in just switching on position or moment, Okay, moment of switching on the circuit, moment of switching on the circuit. ठीक है ना, whenever this circuit is being switched on means what? Means capacitor will behave like a open circuit, will behave like open circuit. ठीक है. And in case of steady state, what happens? We have already studied in capacitors chapter that in steady state condition, then also what happens? Sorry, open circuit to na, voltage to 0 aje, sorry, my mistake. Voltage is 0 na, voltage 0 means when the voltage becomes 0, when it is short circuited. Okay, তো শর্ট সার্কিট হওয়ার অ্যাডভান্টেজটা কোথায়? দ্য ক্যাপাসিটার উইল বি চার্জড র্যাপিডলি অ্যাট স্টার্টিং, ইট উইল স্টার্ট চার্জিং না. শর্ট সার্কিট মানে কি? দের ইজ এ ভোল্টেজ ডিফারেন্স, মিনস ইফ ইট ইজ in 5 volt, it is 0 volt, so the charge will try to flow rapidly because the difference is maximum. In case of steady state, what happens? When the charge gets filled in the capacitor, then the flow of charge reduces as potential difference reduces. In steady state condition, what we assume that for a long amount of time, if the circuit is being turned on, then we can say that the capacity of the capacitor is being fulfilled of getting the charge filled inside, means its voltage is more or less equivalent to whatever maximum voltage it can have inside the circuit. Then potential difference becomes 0, then the current flow stops. Means in steady state condition, capacitor behaves like open circuit. If the potential difference becomes 0, then no current or charge can flow. Capacitor behaves like open circuit. ठीक है ना? Any doubt up to this? I guess it is being clear to all of you. Now the thing is that, তো স্যার এখানে কি হয় স্যার, মানে how things get changed while the switching on condition is being affected or it is being incorporated, that we need to know. In the previous condition, what we have understood, in case of inductors, the charging phenomena we have seen, the discharging phenomena we have seen. So we have to be seeing that same thing for charge flow in the capacitor in case of charging condition as well as in case of discharging condition. So first what we will be discussing is charging of a capacitor. Okay, charging of a capacitor. ठीक है, तो if the circuit is like that, okay, then what we can say, we can very easily say that E is equals to, that is the source voltage is equals to IR plus, what is the voltage across capacitor? Say VC, capacitor voltage. Now what we can do, we can just replace this thing as Q by C. Yes or no? We know na, from capacitor Q is equals to CV, so we can just replace the V with respect to this. Now what is happening, E minus QC is equal to RI. ठीक है. Now in case of steady state, what we know, that the total voltage will be transmitted to the capacitor itself, means capacitor will have the maximum voltage, and that voltage is equal to that E, because there is nothing else in between na. If it is E, this is C, this is R, then this voltage will be transmitted here, so this capacitor will have the voltage E. Then the maximum value of the capacitor charge, if we are taking it as Q naught, that is the maximum capacity of charge capacity, maximum charge capacity of the capacitor. ठीक है, if this thing is there, then what we can say, that E is the maximum voltage, so E can be written as Q naught by C. because that is the maximum voltage that can be there. Okay na? So what we can do, we can just replace this Q naught by C here, Q by C here, Ri. Okay. Now I, what we can say about I can be replaced as well with respect to charge, that is dq dt, na? Rate of change of charge is equal to current. So what we can write, we can write it like this. ठीक है ना? There is no problem about it. Now we can just shift this thing and we can get something out of it, like dq by q naught minus q is equals to dt by rc, or cr, you can write whatever you like. Okay. Now if we just integrate this thing, this equation, integrating both the sides, then what happens, this becomes log e q naught minus q. Now for this minus q, what will happen, a minus sign will come here, and this will be 1 by rct plus k. Now if you remember that we have faced this similar kind of situation earlier, then we have to put the initial condition here. When t is equals to 0, then q, the charge flowing, the charge flown will become 0, because there is no charge flowing then. So if we put this condition in here, so we can get minus log e q naught is equals to k. ठीक है ना? If we just replace this value here in this equation, so what we can get, say minus log e q naught minus q 1 by rct minus log e q naught. Okay, so if we can put it here, then log e q naught minus log e q naught যদি আমি একটা মাইনাসকে ওই দিকে নিয়ে নিই, তাহলে ঠিক আছে, একটা মাইনাস এখানে চলে গেল। ঠিক আছে, নাও আমি যদি এটাকে তুলতে চাই, দেন কিউ নট মাইনাস কিউ বাই কিউ নট ইকুয়ালস টু ই টু দি পাওয়ার মাইনাস 1 বাই আর সি টি, কিউ নট মাইনাস কিউ ইজ ইকুয়ালস টু কিউ নট RCT, and Q can be written as 1 minus. So this is the charging equation. Now it is very much similar to the previous RL case that we have already derived. Only the thing is that there the current was there, now it is the charge here. Okay, so with respect to charge, we can say that this is the scenario for voltage itself, because here capacitance, if it is constant, then charge and voltage we can say it is Q is equals to CV na. So voltage and capacitor charge, that is proportional to each other. We can actually replace this equation by voltage as well. So if we can see here the time constant is a different thing. What we know, a basic equation will have a time constant here, so tau, t by tau is the main condition na, that we have already studied earlier, that 1 minus e to the power minus t by tau. Then this tau becomes of my time constant. Now this tau is here defined as RC. Okay, so this is my time constant for a RC series circuit. Okay, So what is the time constant that we have previously derived as well? We can do it here also, that if we can put t time to be at exactly in this moment, जो भी value होगा इसका, if we can just put it here, then q becomes q naught 1 minus e to the minus 1, and that is 1 minus 1 by e. So we can just calculate it, and we can have a value of e as 1 by e. So we can just have it as 2.718 approx. So this becomes, okay, q is equals to q naught. ठीक है. So 63.2%, if we just draw the graph, then if it is time and if it is q, then the charge is increasing like this, and that moment where it is 63 point, say this is the total, say this is the maximum charge, that is q naught. So this will be q naught into 63.2%. so this time will be tau is equals to RC. So at this time it will have that 63.2% charge filled inside the capacitor, and that time period, how much time it requires, it is called the time period, time constant. Okay, so this is the scenario. And in case of discharging, what will happen? The same thing that we have considered here. In case of discharging, the voltage, source voltage will not be present, na? So this will become 0, means in case of discharging phenomena, discharging consideration, what will happen? This Ri plus Q by C, it will become 0. Okay, so R dq dt plus Q by C is equals to 0. Now this will become, if we can interchange these things, then dq by q is equals to minus 1 by RC dt. If we integrate this thing, then it will become log e q, okay, is equals to minus 1 by RC t plus k. Now if it is a discharging condition, means what? The capacitor was already being charged. Okay, na? In case of discharging, what happens? This capacitor is already having a previously attained charge. If it is q naught, means it has been charged to a value q naught earlier. Now it is being discharging. If it is not having any charge, why the discharging phenomena will come? There is no charge flowing, there will be no equation formed. As we are discussing about the discharging phenomena, means what? We are actually having a capacitor which is previously charged to a value. Now we are considering that value is q naught. Okay, so in this consideration, if t is equals to 0, then q becomes q naught. So k becomes log e q naught. If we just replace this thing, then log e q is equals to minus 1 by RC t plus log e q naught. If it becomes here, then it will be a minus sign, so it becomes q by q naught is equals to 1 by RC t. Now if we just if I just remove the log sign, then it will be q is equals to q naught e to the power minus 1 by RC t. Okay ना, ठीक है. So as we can see it from here, that it is a exponentially decaying circuit. It is an exponentially decaying circuit, as we can see it from here. Okay, so in this case as well, this will decay like this. Now time constant is same as the previous, but the thing is that the definition changes in case of discharging phenomena. we might have not discussed it in the previous video, but the thing is that if we put T is equals to RC here, then Q is equals to Q naught e to the power minus 1. Now if we put the value here, then it becomes 0.368, means while discharging it goes to a value where the maximum values 36.8% charge remains. That becomes the time constant in this case, in case of discharging. You have to remember that in case of charging it is having a different value of percentage, in case of discharging it is having a different value of percentage. So this is the most basic thing that we have to understand about the transient part, and these equations that will help us to build or to solve the sums easily and effectively. These sums can come in the JEE Advanced or JEE Mains exam, so we have to follow up with some sums to actually concretize the part that we have learned. Okay, আমাদেরকে এগুলোকে নিয়ে অনেক বেশি প্র্যাকটিস করতে হবে, then only we will be able to solve the sum in that very short period of time in the exam, otherwise it will be difficult for us. তো এই অবধি আজকে আমরা এই অবধি ডিসকাস করব, কারণ আমার আজকে টার্গেট ছিল যে আমি RL আর RC এই দুটো পার্টকে অ্যাজ ওয়েল দুটো ভিডিওতে যেন কমপ্লিট করতে পারি। তো দিস ইজ ইট। আমরা নেক্সট দিন ইলেকট্রিক্যাল মেশিনস নিয়ে ডিসকাস করব, মোস্ট প্রবাবলি হয়তো ট্রান্সফরমার্স নিয়ে ফার্স্ট ডিসকাস করব, দেন উই উইল মুভ অন টু ডিফারেন্ট মেশিনস, ওকে, লাইক AC মেশিনস অ্যান্ড DC মেশিনস। ওকে, তো আশা করছি আজকে কারোর কোনো প্রবলেম হয়নি। যদি কোনো প্রবলেম হয় তোমরা প্লিজ ভিডিওটা দেখো, অ্যান্ড ইউ ক্যান জাস্ট কমেন্ট অন দ্য ভিডিও ইটসেলফ, অর ইউ ক্যান জাস্ট কল মি whenever you get the time. Watch the video, understand it. If there is any difficulty, just give me a call or text or anything. I will be able to help you out. Okay, thank you for watching. If you like this video, please subscribe the channel. I will be posting more and more videos regularly now. So okay, thank you again, thank you for watching.